We now introduce gambler's ruin as a Markov chain. So consider there is a gambler and he enters a casino with the aim of making N dollars. But he has only X dollars in his pocket. So this X is less than the amount of money he wants to make by gambling. Now this person will walk out when he has met his target of N dollars or he has lost all the money in his pocket. Now this person will choose a game in which he will win 1 unit with probability P. So this 1 unit could be just $1 on every game or some fixed amount, say $1.57 on every game. Or this person loses 1 unit with probability 1 minus P. So this P is the probability of success and therefore probability of failure is 1 minus P. Now suppose P subscript X is the probability that this person will reach N dollars with X dollars in his pocket. Now first thing you notice is that P of 0 is 0. So if he has $0 in his pocket, then he has to walk out of the casino because he cannot bet. So his probability of success is 0 if he has $0 in his pocket. And P subscript N is 1. If he has already made N dollars, then he is already successful. So this probability is 1. So these are boundary conditions. So now he is standing at a point where he has X dollars in his pocket. And we want to compute what is the probability that he will reach N dollars. So this is a Markov chain. The past here does not matter. So the first step is that he bets. And there are two possibilities. Either he wins or he loses. If he wins, he ends up with X plus 1 units. And he wins with the probability of P right here. So P times P X plus 1. Or he loses. If he loses, he has X minus 1 units and 1 minus P is the probability of loss. So if he wins, now he's at a new position, P subscript X plus 1. That is, he's X plus $1 in his pocket. And still you could compute the probability that he will win N dollars considering he has X plus $1 in his pocket. If he loses 1 unit, he still could end up winning this N dollars. So this is the probability that he will still win N dollars considering that he has X minus $1 in his pocket. So what we now do is we rewrite this left hand side as this 1 minus P plus P. So P and P would cancel out and then you can rearrange this to obtain this equation. So now we will rewrite this term as R. So R is nothing but 1 minus P over P. So the equation we are going to work with is this. So this is the equation we are going to work with. So you put X is equal to 1. You have P2 minus P1 as R times P1 minus P0. P0 you have already set to 0. So this is 0. So this becomes RP1. So P2 minus P1 is RP1. Now in this equation you set X is equal to 2. You get this equation. P3 minus P2 is R times P2 minus P1. But P2 minus P1 you have already shown as RP1. So you put RP1 here. You get R square P1. And for I's term you have Pi minus Pi minus 1 becomes R to the power of I minus 1 P1. So notice that 2 is here, 2 is here, I minus 1 is here, I minus 1 is here. And this is your last condition. Capital N is here and then capital N minus 1 is here. So now you can add all these equations only till this I. So if you add them up, there will be a lot of cancellation. This will cancel with this. So the next equation would be P4 minus P3. So this P3 will cancel out. And similarly, this will cancel out with the previous equation, which will have Pi minus 1 minus Pi minus 2. So only thing on the left hand side remaining is Pi minus P1, which is right here. And on the right hand side, you add all these terms R square, Ri minus 1 and take this P1 common outside. So P1 is common right outside. So now you can rearrange this again and you can write P subscript I is equal to P1. This you take on this side. You get 1 plus R square all the way to r I minus 1. This is a nice geometric series. You sum it up, you get p1 times 1 minus r to the power of I divided by 1 minus r. And that is precisely what we have written here. So here r is not 1. If r is 1, then everything is very easy. Then you just plug in 1 here. So if you plug in 1 here, you sum them up. So there are I minus 1 terms with r in it, and then there is 1 here. This will just become I. So if r is 1, this becomes IP1. So this will become IP1 for r equals to 1. This is right here. Now we want to solve for P1. To solve for P1, we will have to add up all these terms too, all the way to n. So when we add all the way to capital N, instead of I, now you write n here, because now this I will get cancelled with the next term here. This will get cancelled right here. So instead of I, you have P capital N. So you will have P capital N here, and you have capital N right here. You rearrange it, this becomes like this. Pn is equal to P1 times all the way to n minus 1. This becomes P1 times r to the power of n. Now P of n you have set as 1. Notice right here this is 1. So if you set this as 1, you can solve for P1. So P1 becomes 1 minus r divided by 1 minus r to the power of n. So this you are just taking on this side. Now if r is 1, then you add up all these terms, and now you have capital N terms. So n minus 1, which have all the r, which you set as 1, and then you add 1 to n minus 1, you get capital N. So again you solve for P1. So P1 now comes out to be 1 by capital N. This is what you write here. So now you can substitute this P1 in this equation right here and right here. So you substitute this P1 here, you get I by n, and then you substitute this right here, and you get this 1 minus r to the power of I divided by 1 minus r to the power of n, because this 1 minus r will cancel with this 1 minus r, and instead of P1 you have written 1 by n, you get I by n. So this is your PI, and you have I dollars in your pocket. So this is the probability of winning n dollars. So what does this r not equal to 1 and r equal to 1 exactly mean? So notice that 1 minus p by p is r. So for r equals to 1, you have 1 minus p by p is equal to 1, and you solve this. This will give you p is equal to half. For r not equal to 1, there are two things. This you can rewrite as r is greater than 1 or r is less than 1. So greater than 1 means 1 minus p by p, this is greater than 1, and that becomes 1 minus p this, or you can say 2p is less than 1 or p is less than half. And if you put here other ways, it's less than 1, then this will become less than p, then p is greater than half. So this is the way you have to keep in mind. So when r is less than 1, when r is less than 1, p is greater than half, and when r is greater or equal to 1, p is less than equal to half. This we have just seen. So these two are linked, they are the same thing. These two conditions are the same. Now you have pi. So what if you want large sum of money, n goes to infinity? If n goes to infinity, this term will go to 0, and that's what we have written right here. And here this term, this r to the power of n, will also go to 0. So this r to the power of n will go to 0 only if this r is less than 1. And if r is greater than 1, then the denominator will go to, this entire thing will become very large, that is will go to minus infinity, so you will get again 0. So pi is 1 minus r to the power of I if r is less than 1. Now let us do this in a practical example and understand this. So say there are two players. So there is a player A and he starts with less money in his pocket. He starts with $10 in his pocket. But his odds of winning are 0.6. So maybe they're playing with the biased coin and the odds of A winning is 0.6. And a player B starts with $20. So A and B are playing against each other. So if A has 0.6 probability of winning, so success for A is 0.6. That means success for B is failure for A, that is 0.4. So now we first set up R. So R is 1 minus P by P, which will be 0.4 by 0.6. This is 2 by 3. That's what we have written. R is 2 by 3. So what is the probability that A will win? So we have this situation right here. This is the formula we have. R is not equal to 1. So this is the formula we have right here. So I is the money in A's pocket. So we are computing what is the probability that A will win here. They keep betting against each other till one of the players runs out of money. So I is 10 because A is walking in with $10 and B has $20, and N is 10 plus 20, which is 30. That is the total amount of money. So one person will end up with $30 and other will have 0, and that's when the game would end. So they're just tossing a coin, which is a biased coin. So if A wins, A gets $1 from B. If B wins, B gets $1 from A. And they keep on playing like this till one of the persons will end up with $0 and other person will have all the $30. So this is the game. We just use this formula here. You have 1 minus 2 by 3 to the power of 10 because I is 10, N is 30. You have 1 minus 2 by 3 to the power of 30. Just using this formula right here, you have 0.98. So although A walks in with less money, A has less money in his pocket and B has more money in his pocket. Just because the odds are slightly more than 0.5, they're in A's favor, that A has a higher probability of winning. So now let us code this in R, and then you can keep on changing this probability as well as amount of money in A's pocket, and then you can see that how these odds change. So this is our function. It has three things. X is the amount of money in A's pocket, N is the total money which he might end up winning, and P are the odds which he has. So this is just the formula we have in the lecture. We have copied it here, and this is the function. A has $10 in his pocket, 30 is the maximum he can win, and 0.6 is the odds in his favor. So we run this, we get the value is 0.98. So notice that if you say decrease the odds to 0.55, you obviously will expect the probability to go down, and that's what happens. The probability goes down. And similarly, you can say if you increase the number of steps, say now you increase the total amount to be 1 is 50, the odds haven't changed by much. So this is you can compute with this a large number of iterations and see what values you get.